Hello students, welcome to the course in operating system. Myself Rafiqul Islam, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology under GIS Group. In previous lecture, that is in lecture 11, we have completed up to shortest job first algorithm, that is SJF algorithm, and we have discussed it using a numerical problem, and it was non-preemptive algorithm. But in this lecture, we are going to start the preemptive version of SJF. This is called shortest remaining time first algorithm. So in this lecture, we are going to start the shortest remaining time first algo, that is SRTF. SRTF, shortest remaining time first algorithm. Okay, so SRTF basically it is the preemptive mode of SJF, and here the criteria of this algorithm, actually burst time and remaining burst time. Using an example, we can verify what is remaining burst time. Okay, and the mode of this algorithm actually preemptive. Preemptive mode. So that's why sometimes it is called preemptive SJF. So preemptive SJF is called SRTF algorithm. So basically, this is the first preemptive algorithm which we are going to study, and we have already discussed FCFS and SJF. Actually, they are non-preemptive algorithm. So this is the first preemptive algorithm. So in this algorithm, short-term scheduler always choose the process that has the shortest remaining processing time. And when a new process arrived in the ready queue, then short-term scheduler compare the remaining time of executing process and burst time of new process. If the new process has the least CPU burst, then short-term scheduler select that process and assign the CPU. Otherwise, continue the old process. So here, initially we have to check the burst time, and after that we have to consider the remaining burst time. Okay, so that's why the criteria actually burst time and remaining burst time. Now see an example. So in this example given, suppose this is process number, arrival time, burst time. Suppose here we have process P1, P2, P3, P4 and P5, and here given arrival time 0, 2, 4, 6, 8 and burst time that is 3 unit, 6, 4, 5, 2. So this is actually given. Okay, now here we have to calculate the turnaround time, waiting time and response time. So these are the common parameters which we have to calculate. So in order to draw the Gantt chart, suppose we consider the another column. This is remaining burst time. So now this is suppose our Gantt chart starting from 0. So to draw the Gantt chart, we have to consider burst time initially. After that, we have to consider remaining burst time, and at the same time, we have to check the arrival time also. So now there are 5 processes in ready queue, and the shortest job that is P5, as the burst time of P5 is 2 minimum, but the arrival time of P5 actually 8 unit. So when time is 0, the P5 is not present in ready queue. So at time 0, only P1 is present in ready queue. So obviously we have to assign P1, and we can assign P1 for time unit 2 because the next arrival time is 2. So we can put P1 for time unit 2. Okay, because the next arrival time 2. So this is the remaining time 1. 3 minus 2, that is 1. So this is called remaining burst time. So now when time is 2, then in ready queue we have process P1 and P2. So between P1 and P2, the shortest job that is P1, because the remaining time is 1 and its burst time is 6. So again we have to put P1 for 1 time unit because the remaining time is P1 is 1. So this is 0. So this is 3. So P1 actually completed and terminated. Now when time is 3, then in ready queue we have only one process, that is P2. We have only one process in ready queue, that is P2, and the next arrival time is 4. So we can assign P2 for time unit 1. So this is P2 for next time unit 1, that is 4, and this is remaining time 5. Okay, now when time is 4, then in ready queue we have two processes, that is P2 and P3. Okay, but the shortest process actually P3, this is 4. So now we can assign P3 up to next arrival time. So up to next arrival time actually 6. So we can put P3 for time unit 2, that is 6, and the remaining time is 2 for P3. This is P3. Okay, now when time unit 6, then in ready queue we have two processes. We have 3 processes, P2, P3 and P4, and obviously the shortest is again P2, that is remaining bus time is 2, and the next arrival time is 8. So we can assign again P3 for time unit 2. So this is again P3, and this is actually 8, and this is completed. P3 completed, terminated. Okay. Now in ready queue we have, when time unit 8, so in ready queue we have process P2, P4 and P5, and which one is shortest? That is P5. So here we have to assign P5 for time unit 2. So this is 0 and P5 terminated. Now we have remaining two processes, that is P2 and P4, and here the remaining burst time of P2 is 5 and normal burst time of P4 is also 5. So we have a tie here. So how we can break this tie? So we know that here we have to check the arrival time. So arrival time of P2 is 2, but arrival time of P4 is 6. So P2 actually arrived in ready queue first. So we have to assign next P2. So this will be P2 for 5 time unit. So it will be 15. It is 0. And now the last process, that is P4. This is 20. So this is also 0. So P1, P2, P3, P4, P5 completed and terminated. So this is actually our schedule chart. Okay. Now here we have to calculate the other different parameters, right? Now we can delete this column. Temporary column, this is actually, okay. So now here we can calculate the starting time, we can calculate the finished time, we can calculate the turnaround time, we can calculate the waiting time, and also we can calculate the response time. So see, starting time for P1 is nothing but 0. For P2, this is 3. Starting time for P2 is 3. Starting time for P4 is 15. Okay, starting time for starting time for P3. Starting time for P3 is 4. Starting time for P3 is 4. Starting time for P4 is 15, and the starting time for P5 is 8. So these are the starting time for P1, P2, P3, and P4 and P5. Now, what about finished time? So finished time for P1, is actually nothing but 3. For P2, finished time for P2 actually 15. Finished time for P3 actually 8. Finished time for P4 actually 20. Finished time for P5 actually 10. Okay. Now calculate turnaround time, and we know that turnaround time actually nothing but finished time minus arrival time. So for P1 it is 0, 3 minus 0, 3. Turnaround time for P2 15 minus 2, that is 13. For P3 it is 8 minus 4, that is 4. For P4 it is 20 minus 6, that is 14. For P5 it is 10 minus 8, that is 2. These are the turnaround time for P1, P2. Turnaround time minus burst time. So waiting time actually turnaround time minus burst time. Okay, so in case of P1, this is 3 minus 3, 0. In case of P2, it is 13 minus 6, that is 7. In case of P3, 4 minus 4, that is 0. In case of P4, it is 14 minus 5, that is 9. In case of P5, it is 2 minus 2, that is 0. So obviously waiting time can be 0, but turnaround time cannot be 0. Okay, so now response time. So response time actually we know that it is fast response minus arrival time. So in case of P1, the fast response actually at 0. So 0 minus 0. But now see, in case of P2, here the first response actually at 3 and the second response actually at 10. So the first response actually at 3. So the response time actually first response, that is 3, arrival time, that is 2. So first response minus arrival time, that is 3 minus 2, that is 1. In case of P3, the first response actually 4, arrival time 4, this is 0. In case of P5, first response actually, in case of P4, first response actually 15, arrival time 6, that is 9. In case of P5, the first response 8, arrival time 8, that is 0. So this is actually response time. Okay, so I think this part is very much clear to you. Now we can easily calculate the average turnaround time, average waiting time, and average response time. Okay, and at the same time we can calculate the throughput. So here the throughput will be total number of process, that is 5 by 20. So here the throughput will be 5 by 20. Okay, so I think this problem is very much clear to you. So now see the next problem. Now see the next problem, that is problem 2 on SRTF. This is actually a gate problem. So here given process number, arrival time and burst time. So this is P1, P2, P3, P4. Okay, and here arrival time given 0, 15, 30, 45. Burst time 20, 25, 10, 15. So here the question is, calculate the waiting time for process P2. Calculate the waiting time for P2 using SRTF algo. So this is the question. Okay, so now in order to calculate the waiting time, we have to draw the schedule chart. Okay, we have to draw the schedule chart. So now starting from 0, and suppose here we have remaining time. So when time 0, then in ready queue we have only process P1. So must we have to assign P1, and the next arrival time is 15. So we can schedule P1 for 15 time unit. Okay, so this is remaining time 5. So now when time 15, then in ready queue we have two processes, that is P1 and P2, but the which one is shortest, that is again P1, because the remaining time is 5 and here the burst time is 25. So again we have to put P1 for time unit 5. So this will be 0. So P1 completed. Now when time is 20, then in ready queue we have only one process, that is P2, and the next arrival time is 30. So we have to assign P2 for time unit 10. So this is 30. Okay, and the remaining time is 15 for P2. Now when time is 30, then in ready queue we have two processes, that is P2 and P3, but shortest actually P3. Its burst time 10. So we can assign P3 for time unit 10. So this is nothing but 40 and this is 0. So P3 terminated. Now in ready queue, actually when time is 40, then actually in our system there are no processes in ready queue when time is 40, because the next arrival time actually 45. The next arrival time actually 45. So here we have CPU idle time for up to, sorry. So when time is 40, then in ready queue we have only one process P2. Okay, because its remaining time 15 and arrival time also 15. So we have to put here for 15 time unit, that is P2, and it will be 55, this will be 0, and now we have to assign P4, and this is up to 55 plus 15, that is 70. So this is also this. So this is our schedule chart. Okay, so this is actually 70, 55, this is 55, this is 70. Now we can delete this column. Now we have to calculate the waiting time for P2. So first, turnaround time for P2. Turnaround time for P2 actually, turnaround time actually finished time minus arrival time. So for P2, finished time actually 55. 55 minus arrival time actually 15. So this is 40. Now waiting time for P2, turnaround time minus burst time. So this is 40 minus for P2 25 burst time. So it is 15. Answer. Okay. So this is the waiting time for P2, 15 time unit. So in this way we can calculate this type of problem. Now see problem number 3 on SRTF. So this is problem number 3. So here given process number, arrival time, burst time. So P1, P2, P3. Arrival time 1, 2, 3. Burst time 9, 4, 9. And here we have to calculate the average waiting time. Average waiting time. Average waiting time using SRTF algorithm. So first draw the schedule chart, and here this is the remaining time. So this is 0. So when time is 0, then in ready queue we have only one P1. And the next arrival time is 1, that's why we have to schedule P1 for one time unit. So this is 8. Now when time 1, then in ready queue we have two processes, that is P1 and P2. But the shortest process actually 2, that is burst time 4, and the next arrival time 2. So we have to assign P2 for time unit 1, and it is 3. Okay. Now when time 2, then in ready queue we have P1, P2 and P3, and which one is shortest? Actually P2 is shortest, because here remaining time 3. So we can again assign P2 for time unit 3. So it will be 5 and it will be 0. So P2 terminated. Now in ready queue we have P1 and P3, and shortest actually P1. So we can assign P1 for time unit 8, so it will be 13 and it is terminated, and at last we can assign P3 for time unit 9, so it is 22. Okay, so this is the schedule chart. This is 13 and this is 22. Okay, this is 5. So now we can delete this. So here we have to calculate the average waiting time. So now first calculate the turnaround time. So turnaround time actually nothing but finished time minus arrival time. So for P1 finished time 13, arrival time 0, so it is 13. For P2 finished time 5, arrival time 1, so it is 5 minus 1, 4. For P3 it is finished time 22, but arrival time 2, so 22 minus 2, that is 20. Now waiting time. Waiting time actually turnaround time minus burst time. So for P1 13 minus 9, that is 4. For P2 4 minus 4, that is 0. For P3 20 minus 9, that is 11. So this is the waiting time for P1, P2 and P3. And now in this question we have to calculate the average waiting time. So average waiting time is equal to 4 plus 0 plus 11 by, there are 3 processes, P1, P2, P3. So by 3, so it is 15 by 3, that is 5 unit, 5 time unit, average waiting time. Okay, so this is basically SRTF algorithm. So as SRTF a pure preemptive algorithm, so that's why it is very important for your semester exam as well as GATE exam and other competitive exam. Okay, so I hope this problem is very much clear to you. Okay, and actually this is already said that SJF actually very efficient algorithm in terms of throughput, maximum throughput. There are minimum waiting time, minimum turnaround time. Okay, but it is very difficult to know the burst time of a process. And in this particular case, here exists starvation problem. So basically, process having more burst time will be starved. Okay, so longest process will be starved here. Okay, so this is shortest remaining time first algorithm. So now our next algorithm, that is priority scheduling algorithm. So which we will discuss in next lecture, that is in lecture 13. Okay, so I hope this lecture 12 is very much clear to you. Thank you for watching and see you in the next lecture. Thank you once again.